Okay guys, back doing the free response section to the test. For problem 1, draw Lewis structures for each. Okay, so you're going to end up with your Lewis structures. We're on free response problem, so you want to show all your lone pairs. PF5, you're going to end up having to split here. And SF4, you end up having to split. And this one, splitting is allowed because you're splitting 2 single bonds. Alright, FCF bond angle, this is tetrahedral. And that's going to become 109.5. Get that from your close book. Hybridization of P in PF5. Okay, there are 5 things around it, so S, P, 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 D. SP3, D. The geometric shape faced in SF4. That's seesaw. Also distorted, you can look at it as a distorted tetrahedron because you have 4 things making it the tetrahedral, and that lone pair distorts all those bonds. Easier way to remember it. In CH4, 4 sigma, the symbol for sigma is a little symbol like that, by the way, and pi 0. Which molecule has the highest boiling point? Okay. Well, the only one, SF4, it's the only polar molecule, and then really it's the dipole intermolecular interaction is stronger than London forces in CF4 and PF5. Okay, answer each of the following here using principles of atomic structure, intermolecular interactions. Okay, explain why the H-OH bond angle is less than in NH3. Okay, well, if you look at this, they're talking about this bond. Oops, hello, talking to you. Okay, ooh, that's ugly. Okay, so they're talking about that bond angle. Okay, so H2O has 1 more lone pair pushing or distorting the bonds into a smaller angle. Explain why the ionization energy of Cl is greater than that of S. Okay, this is a horizontal relationship. So Cl has 17 protons and S has 16 protons, both in 3rd energy level. Thus, Cl nucleus pulls harder on the electrons. Explain why Rb RB is larger than K, so this is a vertical relationship. So you can say RB's electrons go out to the fourth energy level and are thus more shielded from the nucleus. So when you're talking about a vertical relationship, you need to have this word shielding in here. And when we're talking about a horizontal relationship, you need to talk about protons and the nucleus pulling harder. Okay? So we have Br and Br minus here, and they want to know why Br minus is larger. So Br minus has one more electron than Br. Thus, the electron is more shielded from the 35 protons that are in the nucleus of Br. Negative ions are larger than the neutral ion, positive ions are smaller than the neutral ion. Okay, explain why ammonia is soluble in water, whereas pH3 is not. Okay, NH3 and H2O have hydrogen bonds. Remember the statement, like dissolves like. So although everybody here is polar, pH3 is polar, NH3 is more like water because they both have hydrogen bonds. Propane, which is C3H8, has a lower boiling point than propanol, which is C3H8O. So if you do out the Lewis structures on that, propanol is polar, propane is non-polar. Okay, it's basically a simple answer. The propane has London interactions. Propanol, depending on how you draw it, either has hydrogen bonding or dipole-dipole, both leading to a higher boiling point and lower vapor pressure for propanol. Explain why, although they have the same size, ammonia has a lower vapor pressure. Okay, well, if you draw the Lewis structure out, this is what you're going to get for ammonia, and this is what you're going to get for methane. So this here is polar H bonds, and this is non-polar London. So H bonding is a stronger intermolecular force, therefore boiling point is higher and vapor pressure is lower. Good job. All right. The following questions pertain to O2 and O3. So I'm going to stop this one and record a new video later. All right, take care.